Hey guys, welcome to a new video. In this video here, we're going to do object detection using the OpenImagesV7 Pretrained model. So we both have two pretrained models with the Ultralytics ULV8 model. So we both have the COCO dataset and we also have OpenImagesV7. So this has significantly more classes compared to the COCO dataset. So we're also going to do a comparison of the COCO pretrained model and the OpenImagesV7 pretrained model. So we can see what are the differences, which of the models are performing better. Because again, if they have similar performance and we have more classes out of the box with the OpenImagesV7, that might actually be a better model to use directly out of the box. So let's now jump straight into the Ultralytics documentation. Up at the top, we have the datasets overview. We have a bunch of different datasets that you can use directly out of the box with Ultralytics. So if you go over to the left, we both have detection datasets. We have segmentation datasets, post-estimation datasets, and also classification datasets. Right now, we're going to take a look at this OpenImagesV7, where the COCO dataset is normally what we're using for our pre-trained models. But let's now go down and grab this dataset. Let's take a look at the dataset. Let's get an overview, and then we're going to jump into a Python script, do our comparison, and test out this pre-trained model on the OpenImagesV7 dataset. So this dataset here contains like significantly more classes compared to the COCO dataset, and we're going to see some examples in just a second. But we have all the pre-trained models here directly. You can just click on these hyperlinks and they will download it to your machine. But you can also specify the names of the models directly in the code when we create an instance of our YOLO class, and then it's going to download the weights automatically and do everything for you. So up here at the top, we can see that it has downloaded the model. So right now we need to specify YOLO V8 N-OIV7. And if we want to use the COCO pre-trained models, we just need to specify YOLO V8N or the other variations that we have of the YOLO V8 models. So this is how easy it is to just swap the models out and actually just use these pre-trained models on the OpenImages dataset instead. So we have the nano, small, medium, large, and extra large, exactly the same as for the COCO dataset. And we have the size of the images, mean average position for validation set, some benchmarks here for CPU with ONNX, TensorRT here on the GPU, the number of parameters, and also floating point operations needed per second. So here we can see that these are relatively small models, and we're going to see that we get pretty good performance. When we're just comparing it side by side with the COCO dataset, we have lower mean average position because again, we have a bunch more classes inside of this model here. We can also see that this model is very fast. If we're running it on an A100 TensorRT, optimized for TensorRT, we get around like inference time of 2.2 milliseconds with the medium model. If we scroll a bit further down, so if we take a look at this graph here, we have some overall classes and then we have subclasses under that, which is not the case with the COCO dataset. So for example, here we have some furniture, kitchenware, we have a tool, sports equipment, and then we have a bunch of different classes under sports equipment. It can even branch out here to racket, helmet, bicycle, and ball, and then under each ball, we actually have various different sports balls in there. So that is not the case with the COCO dataset. So if you want some very specific classes and you don't have a dataset that you can fine tune your model on. So if you want to fine tune your own models, we also have a bunch of videos here on the channel for that, where you can just grab your dataset, how you can annotate it, set up the whole computer vision training pipeline, export the model, and use it in your own application and projects. So definitely go in and check that. But if you don't have a dataset, you just want to use a pre-trained model out of the box, and you have some very specific classes that you want to detect and also use, this might be the best model to go with out of the box. If we take a look at some key features here, we see that we have 9 million images annotated in various ways to suit multiple computer vision tasks. And there's also different versions of this dataset. So we can see we have V5, 6, and also 7. And then we can see here in V7, which is the dataset that we're using now, we have 66.4 million point level labels on 1.4 million images, spanning almost 6,000 classes. Compared to the COCO dataset, we only have 80 classes. So here you can read about the key features. So here we see the dataset structure. We have the images, bounding boxes. We even have segmentation mask if you want to do object segmentation instead, visual relationships, localized narratives, and also point level labels. So this is suitable for 0, and also few shot semantic segmentation. Here we see the applications. Again, it's just covering like a wide variety of different computer vision tasks because we have so many different classes that we can detect out of the box. So this is the YAML file for a dataset. We just need to specify the path, train, and also our test sets. So this can be used for training your models from scratch. So this is already done. So when you have a pre-trained model, it is just trained for a very long time on this specific YAML file specifying the training, validation, and also our test set. If we scroll down to the fun part here, we can see the number of classes, and we can also see the specific classes that we're able to detect with this pre-trained model. So here I'm just going to scroll through the classes so you guys can see like how many classes we can actually detect. So we have baseball bat, baseball glove, beer, a bell pepper, bicycle helmet, wheel, box, bread, bus, butterfly. So these classes here are definitely not in the COCO dataset, most of them. And if we actually go down to like very small objects, it is more common objects in the COCO dataset. So right now we should actually just have 600 classes in this YAML file, and those can be used directly in your own applications and projects with this pre-trained model on the OpenImagesV7 dataset. So we have all of these classes here. We can just go through them. You can try to just go in here, Control F, and try to search for the specific classes that you want to use in your own applications and projects. So this is how you can use it directly. Just go in and specify the YAML path file here. It's going to download the dataset, train it, but this will take up a lot of storage, as you can also see up here. So you don't really need to do the training here yourself. We have already done that, so you can use the pre-trained models directly out of the box. Here we can see some sample data and also annotations. So this is just like all the different like point annotations, all different classes and objects that we're able to use from the OpenImagesV7 dataset. So we're now jump straight into the Python script. We're going to have a script for the pre-trained model on the COCO dataset, and then we're going to have a script for the pre-trained model with the OpenImagesV7 that we just saw in the documentation. So these are basically just the exact same scripts here. We can just comment this out. This is how you can extract the results, but we already have videos about that, and then how we can actually use the mask, boxes, key points, and probabilities, even like the classes and so on. You can extract all of that in here, but we have videos for that. So first of all, we just need to create an instance of our YOLO model. The only thing that is different in the scripts is specifying the path here. So for our OpenImagesV7, we need to specify OI V7, where in the COCO dataset, we don't need to specify anything, and it's going to download the models automatically if you're running this for the first time. And then we can just throw in our source here, could be a video file, webcam, and so on into the model, and it's going to do inference on that. We're going to specify the argument here, show equal to true. So we're going to show the results while it's doing the inference. And we're also going to save the results here so we can open it up later and just see it after we've processed it. So basically just have a folder here with a bunch of different videos. We can just take a couple of examples just to try to like validate and do the comparison between these two models. So if you just go back again, I already have a video here specified. Let's just copy paste it so we're sure that we're using the exact same one in here in the COCO dataset. So let's just go up and open a new terminal, and then we can just run both scripts and just take a look at the results. So the important part here when we're going to do a comparison is also to take a look at the classes from the COCO dataset. Does the COCO dataset model act like perform better compared to the other one on the 80 classes that it is act like trained on? So right now we're going to open up a command prompt, and we can basically just call Python. Let's just make this a bit larger. So Python coco.py. We're going to run this. It's going to open up the video stream, and we will be able to see the results. So these are basically just some bottles running here in a production line, and we can see that it actually detects a refrigerator here, which is not true, but all the bottles here are pretty much detected. We can see it runs around like 16.5 milliseconds in inference time, and this is just a small model from the COCO dataset. Let's now go into the other one here, and let's just run that. So we're just going to call Python, and this one is called OpenImages.py. Let's run that and see some results. Again, we're going to have the comparison videos side by side. So right now we're predicting drink here, but also all the bottles here running on the conveyor belt. So here at the end, we actually missed some detections where I feel like we actually got those detections in the COCO dataset. The detections were probably a bit more stable in the front, or like in the first couple of objects that it detected compared to the COCO dataset. But let's try to do some other videos. So let's try to grab this video. I'm just going to copy paste the path. There we go. Throw it in here. And we can just run this directly, and then we can go in and take the COCO dataset, change the path. And this is everything that you have to do to be able to run it on these videos. So now it's going to open it up. We can see that it detects the vehicles. So this is for the open images. So we'll probably expect a bit better performance. We're not really detecting the cars over here to the left, which I think that we're going to do with the COCO model. So just cancel this one here, and let's go in and use the COCO dataset. And let's try to see that. So we're going to run our Python coco.py, and let's try to see results for this one. So now we can see that we're actually still detecting, we're detecting a bit more cars over here to the left, and right now we're detecting as a car and not just a vehicle, but we could probably go in and take the subclasses as well. So I feel like we get a bit better performance here with the COCO dataset in this example, but again, the car is also a pretty easy class. So we have this home video here. Let's just try to grab that, and let's test it out on both models again. There we go. Let's just run the COCO model here to start with, and let's see the results. So here I expect to actually get some more detections with our open images. So again, we did dining table, we have an apple, orange, so these are not the correct predictions. We have potted plant bowl, sink over here, refrigerator, microwave, and also the oven. So again, we're pretty much detecting all classes here. We get some false predictions here and there, but let's test it out with the open images to be able to see if we actually have some classes which are not represented in the COCO dataset. So right now we can see that we're detecting a house here, not really true, but we have the cabinet up here at the top, which is not inside the COCO dataset. We have the countertop. We're not detecting these vegetables and also the fruits over here in the background. Now, right now we have gas oven, which was not the case in the COCO dataset. So I feel like the COCO dataset was probably a bit better on this example here as well, but we definitely got some classes from the OpenImages model, which were not represented in the COCO dataset. So let's just try with a larger model here just to see if there's any differences. So right now we're just going to change this to the large model, and we're going to do the exact same thing for our COCO model. When we're changing these variations, it is going to download it automatically, as you can see down here at the bottom the first time. So just try to grab this. So we have the cabinet, gas oven, it gets a prediction earlier here. We have the oven, it didn't really detect that before, I think. Have some home appliance over here to the right. That is not really correct either. We don't get the bowls, we don't get the sink, we have no vegetable here in the foreground, even though it acted like detected that with the COCO dataset. The classes were a bit off, but it acted like did still detect it. So let's now try with our COCO one. But definitely test these pre-trained models here out on your own. It might be the case that you actually have some classes directly inside the OpenImages dataset that you can use directly, which is not represented in the COCO dataset. But it seems like for the standard classes like cars, just the standard classes around your house, people like pedestrians and so on, I think that the COCO model is still better, but it really depends on your application and project, so definitely test both models out. I know that a lot of people are just going with the COCO model, but now we also have this ULV8 pre-trained on the OpenImages model. So that's pretty much it for this video here, guys. I hope you have learned a ton, and also that you now know that we have different models that we can test out initially and even test out fine-tuned versions of them. So I'll just see you guys in the next video. Until then, happy learning.